All right, so one of the things we're working on is we're trying to do bilateral, or no, we're not. We're trying to do radial symmetry, and we're doing it along two axes, right? So what ends up happening is you have this line that's drawn down the center, and it goes like that. There's a vertical line and a horizontal line, right? Which one's the vertical? Straight down, up and down, and then horizontal is side to side, right? So that is two axes right there. The next project we're going to work on 3, but that right now is 2. So then you've got all of your elements that you've made, and right now I've just taken it, kind of arranged them in 4s because we're working with quadrants, right? 1, 2, 3, and 4. So whatever happens in this quadrant happens in this quadrant, happens in this quadrant, happens in that quadrant, and it just kind of rotates around. So if we talk about this, and normally everybody's starting off with like circles, right? So if we take this, and what's generally going to happen in the centers of your stuff is you are going to have a hole in the center. You're going to have a hole in the center because that's just how your circle's set up, okay? So, and then if we take and we figure out what we're going to do past that, if we're working on bases of 4, having 4 things together really pretty much works out. So if we take these, and as long as you do the same thing in each quadrant, you are going to demonstrate radial symmetry. If you start, what seems to end up happening is everybody just starts building stuff and then just starts gluing it together, and then you lose your whole plan and everything's gone. So as long as we have that going on first, that is radial symmetry. After that, we can start and we can add things to that. And no matter what we do, as long as we do the same thing in each quadrant, we start to make radial symmetry. Now we can also put stuff along the axis lines too. And what ends up happening? So the easiest way to start this is to start with your base 4 in the middle and then keep working from there. You will have, if you're doing like these pointy things, how many points am I going to have if I'm doing a snowflake that has points? I'm using 32 elements, right? How many points can I have? Can I have 5 points on there?
No.
No, why?
Because there's only 4 sides.
Because we're working on bases of 4, exactly. So what ends up happening is if you have 5 things going on there, something's wrong. But like I'm showing you right now, if we take all of these elements and we put them together, and as long as I do the same thing to each one, I'm going to end up with radial symmetry. If I just start ignoring everything and start working and just pushing stuff together, yes, it will be cute, but when it comes down to it, it will not demonstrate radial symmetry, and that is the grading criteria right now. You are demonstrating radial symmetry along 2 axes. So that means that you have to have everything in how many?
4.
4. You see what I'm saying? Because there's 4 quadrants now. When we move into the 6, when we move into 3 axes, everything will be on a 3 base. So it'll be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right?
Mm-hmm.
So this is what we're looking to do, and this is how these things get arranged. Does anybody have any questions? All right, so 2 axes, 32 elements, right? And arranged radially symmetrical. Cool. Thank you.